Hello, everyone, and welcome to the broadcast. We're continuing our game development project today. But before we get into it, let's check in with the kitties. We do have, let's see, 3 visible right now. Interestingly, it looks like Mason might be crammed into Sherbet's spot. But we do have Ember and Sammy otherwise. I see that we are joined by Squinnick and Zell. Pride buttons. I've seen some folks doing that, prepping for it. I saw some cute ones that were, they were like little white cats holding knives that had the various colors, color combos. On today's agenda, let's switch over here. So we got a couple of things that we want to work through. I do want to get the movement templated in again so that I can create things at a default and have their movements loaded in. I got the movements working cleanly here. So this is one at a time. I think I've got it capping out like 3,000, and I can show you where the bottleneck happens at that point. So right about there, we saw the performance dip. And part of the reason is here in the upper corners. In the upper corners, around that is the close to the radius of where the spawning is happening. And the reason that we're getting a performance loss is that they're still, they were spawning there and they're being pushed out of that area. So if we go up here, this whole region up here is where we're getting like a pileup happening when they spawn. So as I'm getting out of this radius, we can see some of the frame per second decaying because you can see some of them like appearing down in the lower right. Anything that appears there crepes makes a dessert. Creates kind of a log jam or a pileup. So we want to mitigate that, but that'll come in a moment. What I can show instead, we're going to set it to 1,000. They're spawning 10 at a time. That also increases the likelihood that the issue will happen because they spawn on top of each other. But even with 1 at a time, eventually it will start happening. Right about the time we get a gridlock entirely on the screen. There might be some further toggles we can use for that during navigation to essentially shut it down if they can't move. But here's 1 at a time up to 1,000. And that should be enough to fill the screen entirely. We're still sitting at 60 frames per second with all this nonsense going on. Okay, so we have just about the full screen, which means they're going to be spawning a bit on top of each other out at the edge, but we're not getting that pileup out off the edge. As a result, our frame rate's holding at a nice steady 60. Now, if we are going to turn it up to 50 and show you, it's just going to go up to 1,000, but we're going to turn it up to 50. You can see this ripple effect happening where they're appearing right on top of each other. And you see how some of them have to ripple backwards. I changed it so that the closer they are, the higher priority their navigation is. So they will contract in. Anybody that's closer gets to shove the further ones out of the way. As we run this way, we should start getting them culled. It's going to take longer. I expanded the radius to test that. This is the backlog of entities building up. Well, not a backlog. This is the buffer. Buffering helps. Anytime that we're creating or removing something from existence, an object, we're buffering it now. we have a pool of ones we've used and essentially cleaned out in order to reuse them. That way we don't actually have to create it or release it. We're not spending the garbage collection time on that. So let's contract that radius again, just to show you. Where's our kill zone? Okay, so our kill zone was previously set to just this. And then our visible zone, let's put it at about 1200. We're not drawing them if they're past that. So 50 at a time. They come in at 1,000. That'll save us some pain for the collision logic. We get that nice contraction of them in there. Now we're going to run to the side. We should start seeing them get deleted pretty quickly here now. And we're seeing them pop in 50 at a time. So we're making them at a very high rate. You can see our frames per second holding clean at 60. That's where the engine is trying to keep it. And we're getting a steady swarm as well as the mass behind us that is still active, still bumper carring around there. We've removed self-collision. We don't really need it. I wanted to see the full gridlock scenario where there is an entity right on top of us and everything else piling on. So we're going to walk back to here just to right about here. So the little one that's vibrating in the center there is the one that's locked on. Everything else is at best bumping around a little bit, but there's not a lot of movement happening. So we're able to hold steady about there. If I increase it to, let's say, we're going to put it at 3,000 entities. We're spawning them 50 at a time. And you can see we are still getting some of them spilling off the edges. They're being shoved into the kill zone. Which, I still need to check the ratios on the screen. I feel like Vampire Survivors has a really good size of entity per screen space ratio. So I may, like, increase the scale of the things or zoom in the camera a little bit, just so that we get a better proportion of screen is full versus how many things. Because if we can tighten that down, it will be better. But this is where we sit. I did spend a little bit of time yesterday in the middle of the night because, you know, brain wouldn't turn off. Getting this in line. You can see a bit of a lurch at the end where I do, like, final garbage collection. We are seeing some errors here. Must be between 0 and 1 inclusive. But it always is. Should never be 0. Well, that's new. So we're setting avoidance priority each time we move. And we're setting it to... If the distance to the player is greater than 0, we divide 1 by that distance. So the closer they get, the higher the priority number is. But this is apparently... there's apparently a fail case where it's truncating it. I am capable of saying that, yes. No. Priority less than or equal to less than 0, then priority equals 0. We're going to have an extra failsafe here. I just want to make sure. And we're also going to make sure that this is always afloat. Let's see if we can avoid that. We don't want actual error cases. Warning cases are fine. All right. This will be our 0 case here. Okay. I don't get where we were having that problem, but maybe once the number gets sufficiently high or the number gets sufficiently small, we were getting some sort of like rollover aberration. Okay. Sanity check. All right. So I changed movement modifiers to movement because I didn't like the name being that long. You can also see that I changed all my variable names to be one word to match the rest of the naming convention. Let's see if I can find move straight line. Lump them together. I'll still use internal variables with underscores, but these were getting really long, which made it a hassle to keep them on screen properly. Legibility was good because it was very verbose, but it was reduced because it was hard to keep it all on one line that I didn't have to scroll through. But, so we have move to player. This is doing the lock on to the player thing. I don't know what that is, Squinnick. What is this figure? So previously, just doing this kind of thing was expensive, but we have added stuff like a movement pool. Movement pool is going to be the most complicated one. We have to have a dictionary of arrays for this because each different type of movement needs its own pool. Oh, okay. Yes, the O is silent. We added this just in case. It should never be undefined. It should never be 0. Each of them should be declaring a type. So we wanted to explode if that happens. We might do more of this later. Okay, so first thing, we're going to recreate the old move in a straight line logic. Once we have that functional, move in a random direction in a straight line, I should say. Once we have that functional, then what we're going to do is get the templating done for the entities so that I can supply a default movement collection, create that, when the entity is created from the template, and apply it. So then we have the basis for the spawners. And we could start moving on to that. Once we have the basics for the spawners in place, we could then pivot and start looking at getting that spawn radius logic cleaned up. Something like, spawn them further and further back, and if they're in the death zone, don't spawn them, so we don't get that sort of near infinite cycle of create, delete, which is buffered, so it doesn't really cost us a lot, but it's needless, and it still is currently resulting in extra collision check logic that doesn't need to happen. Okay, so down here. So we need to target random direction. Movement types we have a get, so we need to have that, and we need get target direction. Do I have the targets in yet? I don't. Let's put those in our constants. Welcome, Super. This is not the best structure here. What I'm doing is for each one of them, I'm defining a part of an enum with a value. Ah. We're defining essentially fixed types, and I see the Fallout popularity that has blossomed post the show continues. So these are essentially ways to define which type of movement entity I create from the pools. Whereas with entities with canvases, there's only the one thing. If I ask for a canvas, I get a canvas. If I'm asking for a movement type, every one of these is its own class. Pretty much no matter how I do this, it needs to be defined as an entity, not as an entity, as some sort of object of its own. So we're going to target random direction. We go to our movement pool. We're going to have a case for that. Hello, Vin. Thinking move straight line. Nope. Target random direction. My brains. Hello, cheese, then. I will definitely forget if you keep your screen name different. Okay, so we have target random direction, so then in a movement type, we're going to get target direction. Get target entity and move are going to be relevant for this, but we're making a game, Finn. We're making a game. We are working on our movement logic. Save direction as a vector 2. Check our movement. So we call get target entity and then get target direction on each of them when the thing is created. So on a get random direction, we're going to do this. Not a variable, save direction. So let's see here. Angle is a float is equal to 360.0 times a random float. Now, random float is going to get us somewhere between 0 and 1. Yes. So we're either going to get something between 0 and 360 out of this. We're going to do degrees, 2 radians out of this. I don't know. One of these times I'll have to look up degrees and radians and figure out what the ratio of the numbers is so I can skip this, but this is more legible to me. 360 degrees of a circle, and then some percentage of that. Save direction is equal to vector 2 dot right dot rotated random angle return save direction. So this is always going to emit, when it starts, it's going to emit this random direction. Going forward, when it moves, just can get a copy of move here. Target direction is equal to dot normalized is equals save direction. So it's always trying to face it in that direction. Now I could rotate it, actually. This kind of pushes it in that direction a little bit. Obstinance. You requested if I could, and then you told me to. And that was rude. I'm an entertainer, not a puppet. Lobotomy. So if we save the random angle, we could rotate the angle that to that. So whatever it gets, it rotates it that much. Let's start with this. And go from there. Yeah. Hey there, Lan. Yes. Okay, so random direction. We face a random direction. But it saves that random direction. Human, we are programming a game. We're making a Vampire Survivors style game. We're working on how we determine the movement of our weaponry projectiles. Movement of monsters is straightforward. They do this. They converge to the center of the screen and keep trying to follow the player. We've spent a great deal of time on performance improvement. If we're spawning too many things at once, it does decay our performance as we are moving like this. You can see there's kind of clots of enemies forming on the left. That eats into our performance because there's too many collisions happening. We've tweaked a whole lot of things. We're pivoting away from that performance tweaking right now, just so we can do some other stuff. Now we random direction. Now we're going to look at move straight line. So we've got move straight line. We need to get doesn't do target entity. It just moves. So move straight line does not target at all. It will accept whatever it's given as far as a target. So entity to move dot target movement equal to plus equals direction to use times speed. Now, random direction doesn't use speed because it's not actually attempting to move them. It does. It moves them a tiny, tiny bit. At most 1 world unit. But this one does. This one tries to move them based on the speed. Okay, so if we take this, and we're going to apply this to the blobs instead, just to see what they do. So we're going to set the blobs down to a smaller spawn rate. We're going to go into our entity, since we're hard coding these at the moment. When we create them. So much code. Okay. So we're going to copy that, but we're going to crude but effective at the moment. This doesn't matter. Does it explode? Did I not? Okay, I didn't include it in the pool properly. Where's our movement pool? Okay. Yeah, we needed to add this here. Dot movement type dot target random direction. Target random direction. Consistency. Say enemy. We're going to say enemy, but spelled right. We'll get to that in a moment. But new dot move straight line. New. Okay. So now we shouldn't get nulls. Hey there, Drew. Doing well, doing well. Neom. 60 frames a second, steady number of them. Let us spawn them faster. They are still doing avoidance movement. There's not really any in-game reason to do this, but it looks fun. Let's double check our entity movement. Now I'm wondering if we're getting multiplicative movement here. or accelerating movement, and we need to make sure we don't. We're going to zero out their movement in advance here. Weird that they're going this fast. They shouldn't be going this fast. I mean, it looks cool, but they shouldn't be moving so quickly. And hello, Colin. We're working on the modular movement. We are getting there. We're getting there. So we're calling move multiple times. We call it on our self, which is the entity itself. We have target movement, and we have safe movement. Safe movement we don't really need to keep, but we do. Well, we do anyway, you know. So we zero out the target movement. Delta should be a low value. Target speed is the length of the movement vector that results from this. And we're only calling move after this first time. We add the saved direction in. And this is normalized, so we should always be getting this is always overriding the direction to its saved direction. Yeah, which is about 1. Well, it's supposed to be about 1, but why is it? Hey there, writer. And thank you, Ducko. Thank you. Just double check here. Okay, we're getting different save directions. We're getting less than 1 in each of them, but I thought normalized values were all supposed to be effectively a 1 vector, like a 1 length vector. Let's do a quick experiment. S, which is a float, is equal to save direction dot direction to, I'm going to do length squared so that we can save some calculation there. It's never used, but 1. Okay, that's what it's supposed to be. Okay, so we set target direction each time. So coming in, entity to move each time, at this point, should have a 0 as its target direction, okay? So then we step through this one. Let's look at our move function here. Okay, so we're coming out of this. Our target movement should effectively be 96 in a straight line here. Probably about right. Let's test the let's insert that same test. Squared. Good to have test in here now. Let's reload it. It's not keeping it. That is a big number. That absolutely should not be the number. So this would explain why they're just zooming around. Because even the fraction of that number shouldn't be so big. But why is number big? Because we're setting it to 0, we're going into the movement, and we are passing a fixed target direction in each time. So then we do target random direction. We're going to return a unit direction, a one length vector. We do not. So we're not affected by speed at all in this one. Then we move in a straight line. This is always going to be the same. This is not what we want to do. It's not how it's supposed to move. So the first time it's going to get a given direction, the home and on player works because it's altering the movement in a fixed fashion. But this isn't what it's supposed to be using. Okay. So with this is where we should probably have a target object. This is where we should probably have a target object. Or at least it should return something that we can use subsequently. Yeah, we'll have to check that. Okay, I'm going to step away just a moment. One moment. And we're back. Okay. What do we do here? So when last we left, this value isn't correct. Or at least this is not what we want to be doing. Do we even need to be storing off the movement each time? Because each one's going to pass it along. So I could have it still doing that same thing, iterating over it, saying movement direction, over and over. And anything that wants to can override the next entity that it gets. Let's do that. We'll have to move this into a function shortly. So ultimately, it's going to result Yep, if you'd like to watch in different, yeah, I do have 2 different aspect ratios going. If you're on YouTube, there is a pinned comment to go between them. So there's, the tall form has a link to the wide form and vice versa. Pick whichever is better for the way that you'd like to watch. Okay, shouldn't be jiggling like that. Random direction, where is it? If not save direction. Okay, so save direction starts as a vector 0. So 0, 0. Which equates to 0. It equates to a false value. So if it is a false value, then we're going to actually calculate it to be a non-zero vector. And we're going to return that. Once it has returned that, it always returns that. And away they go. Okay, well, it don't like that. Where are we spending our time? A lot of time in physics. Most of the time in test render physics. Okay. Let's tone down the number of blobs we're spawning at once here. There we go. It was the same problem that we were seeing previously, is because there were 50 blobs spawning on top of each other, the collision logic was going pretty much crazy, since it was 50 blobs spawning on top of each other upwards of 8 times a second. Global variable with progress or something. As far as like meta progression in the game, there will likely be some sort of external storage for that, and as far as internal state of the game, there will be some sort of like pseudo global. Okay, so we now have moving in a straight line. We have our collision avoidance still functioning in this scenario. So one thing you'll see is if they're closer to me, other blobs will get out of the way of the closer ones. Within reason. I mean, they're ricocheting all over the place, but... Okay. We have that. So now we need to get an entity template rolling now. We're going to leave these as mob type for now. Do I want to really change that? Kind of want to change it. Yeah, I want to change it. Otherwise it'll bother me. Oh, welcome back, Tabby Cat. All right, let's see where we explode things. Type template. And like so. We're making a Vampire Survivors style game. So monsters swarming in from the edge of the screen towards you. Still doing proper avoidance. Good, good. We have addressed that. We go into our entity template. Avoidance, collision, yes, yes. We don't need the maybe function. Okay. And export our, which is an array of constants, movement. It can be. It can be. It's usually referred to as a roguelike. I want these to be by name. Can it do the same thing? For science. Type. Hey there, X3. Movement type flag. Find. Nope, nope, nope. We're going to say this. Okay, so what this will do is it should define a series of flags. We're going to try this. Hello, Cat. I will probably not remember very easily because you have no screen name. But hello, I do recall you. Okay, so we're going to call... Now we're going to do an export enum on this template. Export flags, which will be an array of movement types. Like so. And the only flag for now will be this one. I do this. Then this is a live 2D avatar. They are made of an image that is sliced up into various layers, and then it is rigged to move around much in the way of a 3D model, using live 2D cubism usually. And then it's tracked by like facial recognition and whatnot. wanted it to work this way, but I don't know if it's going to work this way. It can't be flags. Can I just do export enum? No. We do this. Because what we want is to be able to open this up and say, which is this, you know? Each one of them I want to be able to select from a list. Is it multi-line text? We do for this. Because I can't export it if it's not node derived, I believe. Yeah. And constant got movement. Is still... Oh. Okay, well, it works. I was just not checking it properly. I was looking at the array size. Well, thank you, Vin. Okay, so the first one is going to be... This is the blob entity, so it's going to move to player still. Hello, Vincenzo. So then if we look at the mouse entity, we are going to say random direction and then move straight line. Okay, we're going to make sure this works. Doesn't explode. Now we need to go into our test render. I'm sorry, when we go into our entity here, when an entity is initialized, we get the template. We're going to go all the way down here to movement. in its entity template dot movements. Do this movement is equal to pool dot create, and it will be movement type. Then we also need a speed on that, actually. Floats. So then if I look at our template 1, our movement speeds should be, we're going to put 96 there. And then for our mouse template, we can leave 0 on target random direction. Go into our entity again. Movement dot speed is equal to I in entity template dot movements dot size. I. So movement speed, entity template. Fat fingering everything. Speeds I. Movements dot append movement. Movements is an array of movements. Yeah. Just to be sure, I guess. Force it. Can I do that? I cannot do that. Oh well. Hey there, Dodd. Welcome, everyone. Welcome. Okay, so this should make the blob still move proper here. Blobs are still locked on. Good, good. And mice, we will now make spawn as well. Very nice. Now we do need to change it so that the spawn rate is based on delta, not on physics frames. Because right now things spawn multiple times a second. That's not really what we want all the time. Ultimately, what I'd like as far as spawning is to have two values for spawning. One is how many in a burst, and then how frequently a burst should happen. What's the gap between bursts? So it would say something like, hey, spawn 10 of them using this behavior, and then wait this long before doing it again. So I might do 10 at once, but do them in an arc, you know? Okay, base movement is in place, and we have no errors. Good, good. And I think movement is still set. So next up we need to start looking at spawning. So what we can do is define... Right now, blob space and mouse space are just generic names. They don't actually need to be everything that they are. So if I look at test render, there's a lot of footwork going on that really isn't what that area is supposed to be doing. Like, it's not supposed to decide what to do with a collision. But it is supposed to know how to get rid of things. But it ultimately doesn't need to. We could have a queue deletion logic baked in, but it has to happen clean. Let's think on this. So currently, each area has its own pool. So this area knows everything that's part of it. Don't really need that. It's not going to need an entity template. It won't need that. So, for example, the blob spawner keeps track of all of the blobs that have spawned, and will interact with them accordingly. We're going to need to add a signal from each blob that tells the holder that it should be removed. So the entity itself can say, I'm going to ignore all messages going forward. But then additionally, that the thing that holds it can properly set out deleting it. So it can queue it for deletion. It can remove it from the collection properly. And then it can update the indices that help it identify which entity we're dealing with. Yeah. Okay, so we need a new concept of a collision zone. Do I still have an old one around? Yes. Collision zone extends an area 2D. We're not going to care about enter-exit here. We may need the on-ready still. we still need that. And then we'll need a way to handle this. Okay. Does test render have a scene? Yeah, test render has a scene, and then we have bound a pair of events built into it. Okay. Okay. So a collision zone should have the same thing. I do, Dud. What the blobs are for is going to come a little bit later. Initially, the opponents are going to be a little more basic stuff. Generally kind of like a soldier sort of thing. The blobs are different. The blobs are kind of special. I'm just using them because it was fun to make the sprite initially. Same with the catbot. I already had that sprite ready, so it's already in there for the player character like it will be. And then the blobs are ready for when I get around to them. We shouldn't need texture path anymore. But we will need these things. We might not actually need the map RID here, but we'll keep it for now. Spawn limit here isn't really a thing. That's going to be more on the spawner side, but we'll keep track of that. We don't need total spawned. We will need entities to delete. Move in is irrelevant now. Same with spawn rate, speed, all of that goodness. Collision count, delete count, time since delete. We don't need those. Entity template will be part of the actual spawner. Okay. So it is a collision zone. We need to create a new scene for that. What's our naming convention on scenes? Should have the same file name. Just so. And it's going to extend we're going to attach a script. We've already got that, so we have that loaded in. So then we are going to go into this scene. We're going to look at the nodes. We're going to attach area shape entered. We're going to connect that. Area shape entered. Make sure we connect that one. Right there. So then we need to start porting some of this stuff over. So we have our on collision. We need to keep this for now. Will not be handle collision. So gonna need a little flicker there. That was interesting. So and everyone else, if you're curious, the whole theming of the game, the background or the lore of the game, will be based a lot on the character lore, like my lore. Effectively, it will be kind of the story of the Catbot Corporation as it exists today. If you've kept up with what generally goes on in the lore, you'll have an inkling of that, especially the folks that have been with us for quite a while. A lot of this stuff goes all the way back to our Noida mod back in the day. We need all of this, but it's going to be entities. These. Wait. Okay. Okay. So at the moment, we'll have two different areas. We'll have multiple areas, but we have the concept of the player, which can be a very different sort of thing. We don't need to have the player be a core entity. I think it will be, but it won't need to operate the same way, let's say. We'll probably still let it do all of the footwork as far as like setting it up, but as far as movement, it will behave differently, and we're going to treat it as a special thing. We don't want to spawn them in there. Hello, Blueberry. Welcome, welcome. We're going to do physics process. In that physics process, we're still going to do the deletion. Effectively this. So we need the entity, entity. And in remove thing by thing. This is a coding stream. It is going to be a very chill experience. If you want to chat or if you have questions or similar for me, just fire away. I cannot in any way guarantee that I won't be entirely distracted, but I try to respond to everything. On exit tree. So here's clearing all things. This is removing each thing. This is updating the indices. We technically need to do this after every one we delete. It's messy, but we should. Okay. Yes, and we are doing that. Okay. Okay, so this is a failsafe. It's when this area leaves the world, when it's removed, we clear out every entity that was part of it. Quandale, hello, hello. I don't. Forgive me, folks, my memory is terribly unreliable when it is not really reliable. Okay, so that's all the collision logic, more or less, as well as deletion logic. We will need a signal for something to raise that says, essentially, I am an entity that collided. Get rid of me. And each entity will need to have collision logic. I think collision logic might be an opportunity for us to socket in more handlers. So things like when this thing collides, it will it has various collision handlers that it will call through. So projectiles will probably have a collision handler where they assert an impact on something else and say, I'm going to do 10 points of damage to you. If the other side of the impact doesn't care about that, it doesn't care about that. But we'll have to handle that kind of thing. Okay, but each collision zone is now a thing. And we could have a spawner know about a given collision zone. Yup. Navigation agent is different collision zones than have collision. Okay, they have their various avoidance layers. As well as priority, but we don't need to worry about that just yet. We need to make sure these are getting set, so ready function, we need this kind of stuff. So we get our local area, our RID, we get our world value, we get our navigation map, which we're going to use for any entity that gets added to it. So again, once the spawn happens, they exist in that world zone. Yeah. So right now, if a collision happens, all we're doing is removing the associated entities. So the next thing we want to do is set up a spawner. And that spawner will have an entity template that it'll use. Likely we're going to have some translation out of the entity template, since we want to have the ability to change what the movement collection is without messing with the template object itself, I think. We can test that in just a moment, though. Hello, Sky. Sky can be very chatty if you talk to him. So he's getting chin scratches right now. With a lot of cats, one of the ways to ensure that they'll let you pet them without like running off or taking a swing at you necessarily, sometimes just approaching them will make them afraid enough to go hostile. But if the cat is uncertain of you but might let you pet it, holding your hand out first, and don't just let them sniff. It's if they engage contact, then they want you to pet them or similar. So hold your hand out, and if they rub their face against you or if they run their body along the hand, that's usually them saying, "This is where I want you to pet me." And if you do that, they're more tolerant towards it, usually. Individual cats, individual personalities, but that kind of thing is part of the body language. And cats are very big on body language. Okay, so now we need to add in collision zones. We need to add a spawner entity. We don't need kill zones anymore. This entire mob concept has effectively decayed to nothing but the player. Spawner behaviors and whatnot, most of this folder structure can be moved elsewhere. Positioning is going to be part of spawners still, mostly. Position modifiers are definitely going to be something. They live nearby any individual projectile. So what I'm thinking is, here, let me show you. I brought this up for a reason. Okay. So we have our base where, come on now. Why you no draw? Welcome back, Vin. Weird. Ah, I see. MS Paint. Okay, so we have an entity. This is what like everything is. That entity has movements, or it has a movement variable here. Each one of those can be like several different entities that we go through in sequence to determine how it moves. So this one might be, you know, find a target. This one might be face the target. And this one might be move forward. Now, interesting thing about find a target, face the target, move forward, you could view this as homing behavior. But this also could be considered like, I have a target that I am looking at. I am looking at the player. Face target could be, I could have face target once. So whatever it was given, it looks at that target, and once it's given that direction, it never changes that direction. So you could do this as target a random enemy kind of thing, where find target could be a random enemy, then face that target and move at them. And that could be a fixed direction. But like the way the blobs move is they say move to the player. They don't care about finding a specific target. They don't care about anything special. It's just find where the player is and move closer to the player. Now, with positioning, that's where when we spawn them, like, how many are there and what pattern? Look at this handwriting. Look at that handwriting. Isn't that nice and clear? So I might have, from the player, I might fire out in a spread of 3, or it might be, 1, 2, 3 burst kind of thing. So this would be, there's 3 of them, fire them in a spread. There's 3 of them, do 3 in quick succession. That kind of thing. That's what position is going to be about when it moves them. So first you determine the position of a given spawn event. Then you determine how, in part of that is how many of them and how am I going to do it. And then I assert the movement for all of them. For the most part, what this ended up being in our first iteration of this movement logic was, I take that first one and it says, okay, I'm going to move to the right here. So like this one moves to the right. Then I tell all of the other ones, you're going to have the same target information initially. So they'll all have the same information that the first one generated. But then I'll go through the logic and say, okay, for each one of you, I'm going to adjust things. So I'm going to need to have logic for things like asserting a change to the direction that it wants to have. So, get the direction that it wants to move, rotate it. If I do a 3-shot spread like this and it's a homing projectile, that won't change a lot. But if it's a projectile that moves in a straight line, each time I'm iterating over them, I'm saying, okay, this one is rotated this much, this one is rotated that much. So it goes from flying a straight line to the right to, angle up, angle down, that kind of thing. So should be interesting. We are going to step away for a couple minutes again, and then we're going to continue. And we're back. Hello there, Sniper. Okay, so we've got our collision zone in place. Now we want a spawning entity. It's going to be a node. I think it needs to be an actual node so that we get the physics process. Would also let us attach it to relevant things. But it need not be that way. The player object could be keeping track of all of its various weapon spawns and iterating on them. Just like the global monster spawner could be a special thing, such that I don't have to invoke the node structure unless I really want to. Because again, nodes are expensive. Let's start with it being a node and we'll go from there. So now we've created a spawner again. Function, we have physics process. Each spawner will have an entity template. And let's see. Target zone to spawn to, which is a collision zone. That way, it's entirely where we spawn it that matters as far as how we're going to treat it. So it's the idea that we spawn the behavior of the entity as far as how it maneuvers around is initially determined by the template. But ultimately, it's the zone that determines what it's considered. So as far as it being an enemy, when an enemy is collided with, that's entirely because it's in the enemy collision zone, not because there is something fundamental about it that makes it an enemy. There will be correlational kind of stuff. So enemies will all have the move towards the player movement, but there'd be nothing stopping a projectile from having a move towards the player movement. Okay, so this needs to be set on a spawner to get it to work properly. So we instantiate it, we do that, we assign it to some part of the tree. The more I think about this, the less I like it. I feel like we should just have a, process spawn kind of function and have any entity that interacts with a spawner decide when it will call the spawn. For the most part, it will be on physics process with a delta. But we'll see. We shall see. We'll start here. So let's see, it'll have a variable Okay, spawn interval will be the same as delta as far as its composition. It'll be in terms of seconds. Spawn is also a float, and it defaults to 0. In physics process, we will always say time since last spawn plus equals delta. And then this will get a little tricky. We have time since last. We're going to say while equal to spawn interval equals spawn interval spawn. Okay, so then our region, our collision zone, we hand an entity to that collision zone. So we're going to have a which is entirely tricky. Let's look at our test render here. So we call add thing. Where do we have that? So we're determining where to put it. This will vary based on different things. Same here. This is irrelevant. Largely irrelevant. We create one, we initialize it. We set its position. We append it to the collection. Okay. This is the flakiest part of the process. If we give a thing to it, and it's not the one that initializes it, there's a gap in the handling. So if I create this entity, if it doesn't go into the thing collection of the collision zone immediately, then the identifier here can be off. So I think when we're adding a thing, we're going to hand it a template. For now, it's just going to be the template. If we hand it the template, then it can do all of the extra footwork. Okay. Just take that. And collision zones don't have entity templates. Yes. Okay. Hello there, Mia. Welcome. entity at we're going to temporarily have variable move in. No, no. Spawner is going to decide where to put the thing by default. Which is going to be part of the positioning logic. Okay. For now, we're just going to do this to make sure that the blobs are set up properly. Okay, by having this in sequence, we ensure that the entity pool, when it adds it to the area ID, that we should still be in line here. This is still nasty logic. That by coincidence, when we add the entity to the local area, when we add that shape, that it lines up here. That's not pleasant. In theory, we could dodge some of these issues by having entities be shape 2Ds and just having them set up that way. But that still leads us into the problem of having to track the shapes. That would put us into the area, the issue of having every entity be an area 2D, which is extra collision handling. Extra logic to deal with. Might we circle back around to that sometime in the future? Maybe. Maybe. Hopefully not. This lets us very tightly optimize it. And I think eventually what we're going to do is we're going to have an entity template at some point during the spawner, but there will be something else passed in. So it'll be entity template, but there will be, say, an array of movements that will override what's in the entity template if it's present. Same way that the position to use should override it. Oh, but that we're going to create it. We're going to assert the position. But until it's created, we don't have the movement. This needs to be in the spawner. Ew. Ew. Cooking indeed, task. Cooking indeed. This goes in the spawner. So we need to get these. Sometimes Gordon Ramsay's programs are fun to watch, and other times sometimes he feels very passionate about good cooking, and sometimes he just seems pompous. Or both. How long have I been coding total? Decades. How long have I been coding this? About over 120 hours. So when a spawner is created, we need to give it a target zone. Like, it has to have a target zone to work. Kitty, yes, that kind of creature is very wiggly. Almost entirely wiggly. I would say it needs an entity template to start functioning too. So we can't really create one unless we have a target zone and a template. If you try to create one without these, it can never work. You can change them subsequently, but it has to have them at the start. Yeah, I'd agree with that, Dots. Uh, I mean, I could also say Cami. I feel like Cami would have been more appropriate to use as an abbreviation. Sexuality can be a significant part of a person's existence, but I feel like using it as part of a person's name is a strange territory. Well, if you do step out, Eldon, thank you for joining us. The hardest part of making this game, well, there are a couple of difficult things that have been there. One is learning how the Godot engine behaves. There have been a lot of idiosyncrasies. Like, one of them is we've come up with the pool infrastructure where we're buffering everything. If we create an object, it's from a buffer first. because creating or deleting anything at the frequency and numbers that we're doing is a huge cost to performance. It is rivaled only by extensive multi-object navigation logic at about 3,500 objects in the same general area in cost. Just creating an object that encapsulates 2 simple types is more expensive, per object created, is more expensive than having those objects try to maneuver around each other every frame. So we've got that buffering. That's one of the elements, is dealing with that. Learning the scripting hasn't been difficult. Preventing myself from perpetually trying to tune the performance better and better and better has been a struggle. It doesn't have to be perfect, but I like it to be really, really good, and it's finding that line. Finding the point at which I can accept that it's good enough, if only for now. And that's kind of where we are at the moment. By default, we'll have a spawn interval. And spawn interval is greater than 0. We require that the spawn interval be set to something other than 0 for spawns to happen, which gives us a timer to operate on before we start spawning things. Okay. Okay. So if one of these is in existence and we set it to have a spawn interval, then we should start getting entities. So if instead of having a test render, we create a collision zone, so let's go into our game, and we are going to set these to have spawn rate of 0 and a spawn limit of 0. So they don't try to spawn. And then we're going to add a collision zone, just so. Then we're going to have, so we create the player, we add the camera. We're going to make a new spawner, which needs a template and a zone. So the template is going to be our blob template. We're going to load one of these. And then we are going to say that its target zone is that. Let's say spawner dot spawn interval is equal to 1.0. There's that explosion. There it is. Okay. Okay, and then in our spawner, target zone, add entity, new entity. Okay, I see what. Add child spawn. Remote core game, node, collision zone, spawner. Okay, and then in our spawner, initialize it. Okay. We don't have a draw loop happening, I think. Yeah, we need the draw loop in the collision zone. And we'll need to fix the thing, the text display. When we are being drawn, I think this is what we'll want to override here. We might do physics, we might do process again, but I feel like draw is more accurate. Or entity in entities, just draw. Entity in entities, entity draw. We're gonna want to. We're gonna put this in process. Okay, they're not moving yet. entities, entity, not be move. There we go. Now we are going to go into our blob template here. Avoid collision zones, collision, then it will... There. Okay, on collision, I can have them spawn much, much faster, but we're going to avoid that. Sure, the collisions happen. Collisions are not actually happening. Okay. Lives on 3. And it looks for the player in the player bullet. Yep. Look at a collision zone. Ah, that's why. There we go. There we go. That second number is still tracking properly. The lower number is still tracking properly. Second number is the number of... I think it's our shape pool, actually. Okay. Then if we go into our... spawn interval will be twice a second. And times a second. Yup. Making headway. Okay, now we will do the same thing in the game code. Instead of that, we'll have you there. Get another collision zone. It's the bullet zone. Same logic, and it will be, instead of the bullet zone, actually, it will be the player that it is attached to. Okay, you can see the mice are not spawning correctly because its point of origin is still, by default, the spawn zone around the edge of the screen. But we can correct some of this by making sure that the bullet zone lives on the right layers. I have robotic cat ears and a tail that is a giant, like, high voltage charging cord. Make whatever decision from that you would like. So then if we do remote, player, we have the bullet spawner, and its interval will be 0.1 as well. Okay, and the mice are impacting the blobs. We're not actually running into a problem right now. Things are working. Things are working. Blobs are spawning. We have more control over the spawning logic. Mice are spawning. We do need to set up a concept for the positional spawning. I know, right, Drew? It's weird. No, I don't think we have distance despawning set up. Do we? We don't. We are zoomed out 10 times. Look at the number of mice. Can you see the little speckles on the screen? "60 frames a second. Let me zoom in a little bit. If you are on a screen format that can see that you can do a widescreen, there is a link that can take you from the tall form to the widescreen format. You might be able to see the screen more clearly when that's done. Let's do 0.5. Hey there, Chow. So these mice are not being despawned. They're never despawning. See, they're like 3+ screens out. Yeah, there's like static here. Let's see if I can. Hey there, pause. One, our performance values are doing great. We have entities that are navigating off into oblivion. You can't really see them very well, but they're off in gray space here. And there have got to be hundreds of them at this point, going off the screen. And because of the way we're drawing them, they are being drawn. As in, we are spending cycles of time rendering these, even when they're completely off camera. And there is zero cost happening. Liken that. Liken that. So if we do 0.1, we'll zoom in a little bit. And then we're going to go into our intervals here. We're going to spawn them really, really fast. Okay, at this rate, we're starting to slow down. Now, is it the blobs or is it the... Okay. At this point, I think we're finally starting to slow down. DBZ, I have 2 streams because they are in 2 different formats. The one that you're in is in widescreen format. 16 by 9 screen ratio. The other one is in 9:16 ratio. Your more cell phone vertical format style. Oh wow, we got a triple. Oh, not that one. This one. So there's Mason, Sherbet, and Sky, in order of top to bottom, left to right. Okay, we are going to go in and we're going to have in our UI update here, we're going to change this to be entity pool. I think it's entity pool.size. Armillary, or Armillare. I think it's Armillare, right? Looks a bit like Armillary, you know? those are 3 of the 5. The top one is Mason. The one on the left is Sherbet, and the gray and white fluffy one is Sky. Not visible right now are Sammy and Ember. Ember is on my lap. They're all sweethearts, and I try to keep as many of them on camera as I can at any given time. Okay, that's not what I want to track. Let's go into our entity pool. Actually, where is it? Enemy zone. A collision zone is equal to this. The bullet zone. Yes, this is Godot 4 point something. We're using GD script for it. Largely just because. The GD script part, not the Godot part. Enemy zone should always have entities. Yeah, okay. String that. String this. Interesting. Just using the right slash for that to begin with. Okay. Do. There we go. Hey there, Protective. Okay, we have created 200 bullets. Let's go to town on how many we have. Zoom the camera out to 0.1 so we can see it operating. And don't worry if you see Nightbot when you are on Twitch. I haven't removed that yet. As far as its jump in, it's not targeting you specifically. I don't think there's such a keyword. Let me see if there is, though. If I had to guess, is that like a closure or a what's it called? Oh. Yeah, there's no guarantee that a function doesn't have side effects. Lambda, that's what I was thinking. Okay, so we're zoomed out. We're going to spawn 0.1 a second. And not really worried about blobs. Hey there, Don. Spawn mice faster. For those that haven't been here since earlier, we are making a Vampire Survivor style game. This is day... what now? This is day 41. About 3 hours a day, some days longer, some days a little bit shorter. As far as raw coding. We've got things performance optimized pretty well. Right now, setting aside blobs, the first number, there are about 1,500 of the little wind-up mice moving in a random direction from where they started. And they're flying into oblivion. We are not removing them. In the actual game, we will be removing them, because there's no need for these out here to exist. But the advantage being, every one of these is navigating using the built-in Godot pathfinding logic. Now, they're moving in a straight line. It's not like they're dodging, but they can. Like, the blobs can dodge each other. We're sitting, and the way the rendering happens, there isn't really any culling happening. It's all of these little mice are being rendered to the screen space. And that screen space is infinite. So it's not like it's being visually occluded. It's not like they're not being drawn. We're still going through the trouble of drawing them. Now again, normally we wouldn't. We would just say, hey, you're too far away to see at all. Just don't draw it. We'd have to do that manually because we're doing the drawing at a low level. But it's not until about 3,000 of them wandering into oblivion that we're starting to see the frames drop. So feeling pretty good about that. Let us make a small adjustment. Instead of using the mouse spawner, we are going to remove you. No mouse spawner. And we're going to go into our blob template, our blob test template. And instead of move to player, we're going to do random direction, move in straight line. There they go. All right, let's start doing our adjustments here. Gonna go in, we're gonna zoom way out. And we're going to greatly increase the number of blobs that we are spawning, 10 a second. Now, the difference with the blobs is they won't run into each other. If you watch, they'll glance off of each other. The closer they are to the player, the more movement priority they have. If a blob is closer to the player than another one, the closer blob shoves the other blob out of the way. So the reason we care about this test is I just want to verify at what point frame rate starts to plummet when we have navigating, like, colliding blobs. Like, over here we have a cluster of, like, 5 of them that are constantly bumping into each other. Here's another cluster of 5. Again, from a practical perspective, at a bare minimum, once they would get this far out, we're getting rid of them. We don't need them. And once they get past, like, this area here, we don't even need to draw them, because the player definitely can't see them past that point. Okay, 1,500 things. Closing in on 2,000 blobs, moving and bumping into each other. So again, there is a built-in navigation logic in Godot called the navigation server. And there are kind of GUI elements that you can use, the drag and drop kind of built-in elements, called like navigation maps and navigation agents. At about 2,500, 2,250 or so, we start to lose frames as far as what's going on here. So let's go into our collision zone. Actually, what if... Hey there, Noah. Welcome. And welcome everybody that joined since the last time I said hi. Okaneki joined us, so you know, hello to you as well. So let's... What about our core player object for now? We're just going to use this. Static. What I want is to just be able to call it on the player here. Float. Position is a vector 2. Other position. We're going to put it in the player factory. Long term, it won't be called player factory. I'll call it something else. out. Okay, so then in a collision zone, don't know that this is ultimately what we want to be doing, but yeah, it'll do. It's the 1900. Then draw. Then when we call entity move, let's say I'm gonna give it a really generous kill zone. I wouldn't know, Apple. All right, let's do our zoom out and amplify here. Oh, we have to make sure that we clear them. Okay, we can see that there is a line that they're not passing here. Let's reload. Let's expedite some of this hoop jumping that we are doing. Okay, so we cease to draw them past about here. Past about past about here, they cease to exist. Hey there, Sans. Okay, at about 2,500 ricocheting into each other, randomly like this, we start to run into issues. collision is still a problem. Collision is still a problem. We don't want them to... If we're not drawing them, we could ignore avoidance navigation. And say, if you're too far away, we don't care if you bump into each other anymore. That would be a possibility. We're going to move clear image up here. And we're going to set visible. Yeah, I like the switch over to piano 2 as well, Sans. Didn't need to say as well. Anyway. Okay, so we can set visible to false. Yeah, so what we're going to do is in our draw, if visible, then we do that. This is just solo piano stuff, Sans. I do have a link in the descriptions of my streams that is to the Epidemic Sound playlist that I used for this. That's just piano stuff. Technically, this will still work. Okay. Okay, so then in our collision zone, if it's outside, we say we're still always going to call the draw code. Say entity visible is equal to hello, Sherbet. It is, Don. It is a lot of kitty cats. Sherbet left there to come over and leap up onto the back of my chair. And thank you, Sans. I appreciate the compliment. Visible is less than that line. Then we just call draw. Always call draw. So then if they're not visible, we can also go in to the entity. Potato indeed. Then we can set avoidance enabled. Okay, we'll reset these. So what we'll do, collision and avoidance layer. We're gonna try some things here. Yeah, visible. Else. Sherbet seems to be snuggling up with his brother there. Okay, so if we're visible, we will still use our collision layer and avoidance. If we're not, we won't do that kind of navigation movement. So as soon as they cease to be visible, they stop caring about running into each other. All right, that's slowing down the collision issue, but we're still getting plenty of collisions here. So this didn't really help. I like the visibility change though. For the drawing, simplifies it. Which part? That's where we did. Yeah. We set whether it's visible and then we call draw. And if it's not visible, it just clears itself and doesn't do anything with the extra logic. We could do a screen detection around the player. And have a quick check and say, is this entity within like half a screen of the screen? If it's not, just get rid of it. Um, 60 times 960 plus. This should tighten that up a little bit. Not perfect. It's like right at the corner where it'll happen. We could expand that a bit. And then we can tighten the kill zone on it. This is a really brutal case scenario because they're still spawning very rapidly and they're kind of like vibrating around each other. So we're getting a lot of collision cases. this is containing the number of things pretty well at the moment. Effectively, we should be culling them by the time they get about here. Or at least we're making them invisible when they hit about this corner here. And then they go away if they hit this corner here. We could calculate this as a square. It's a fiddlier calculation. There are more checks, I should say. Could do like an absolute value check and whatnot to check if it's in a square, but distance squared is pretty solid. Still holding steady. All right. Stress it a little harder here. We're going to go into our blob template again. And we're going to set it back to its prior type of movement, which is move to the player. Now, spawning is unbounded. We're going to keep adding them. One of the things that I want to do is make it so that the spawning happens further out, so that we can get a more constrained radius here. I mean, overall, that's looking pretty solid. So we've broken free of the main mass here. Okay. Okay. Now we shall add to the same extent. We are going to add a we're going to add the mice back in. Mice spawn in the same area, but they spawn and they move outward. Again, our positioning logic is not put into place yet. Positioning logic is going to control where they appear and in what configuration. If we move left and right, we can see the mice are spawning at the edge of the circle, more or less. And they move in a random direction. The blobs move in. So these numbers are being constrained pretty well. Yeah. I think we've made some definite progress here. Let's look at this from... We're going to go into the spawner and we're going to add something temporary here. Okay, we're going to add a little hack here to the global spawn position. If entity template movements.size is greater than 1, else factory player position is this position. Okay, so if it has more than 1, that will mean that the mice spawn on the player, the blobs spawn on the spawn zone. This is just a hack to verify here. So the mice radiate out. Hey there, Yassine. We are stress testing. Frames per second. Steady 60. Okay, let's just zoom in to see how it looks. So we'd have to expand the visible area a little bit here so that you don't get this empty corner on the screen. Okay, we're holding steadily at about, let's say, 800 objects. Our entity pool is keeping healthy and steady 60 frames a second. We are getting some flicker from some of the objects still. I'll need to make sure... Actually, should be able to do that, right? Further testing. We go into our collision zone. And ordering Y sort enabled. There we go. It removes the flicker. Gives it a neat effect towards the center there, didn't it? Yeah, I like that. Oh, congratulations, Conrail. Yeah. Okay. So, progress for the day. Progress today. Do. Well, thank you, Conrail. So let's see. Today, well, all right, we'll start from last night. I got the entity pooling in there. So we have tightened performance optimization down as far as at the moment, I think we need to, for the purposes of rendering and collision. Spawn-wise, I feel like we're in pretty good shape. We still need to iron out where the creatures spawn as far as like how far away to minimize the number of navigation bumps that they run into right as they appear. But with the parameters that we've got set for draw range and spawn, like survival range for the creatures, we seem to be in pretty good shape. Like I was saying, about 800 things constantly present, monsters moving in, bouncing off of each other, and projectiles flying out super fast. Everything spawning 10 times a second. Actually, it's technically 100 times a second right now. Spawning super fast. And we're holding steady at a flat 60 frames per second. Everything is good. Hopefully, our next target will be position of spawning, where they appear and in what configurations. So this will be 3-shot bursts, spread shots, that kind of thing. Once we have that sort of logic in place where there is a parameter that says how many and in what way do you spawn, and then a chain of events that say in what way do you move, we will be in a position to start creating the first weapons, the first default weapons. Before we formalize the weaponry, we might experiment with getting the modular nature in there to have a spawner either recreated or similar. So maybe a spawner pool kind of logic. We'll see. We'll see. But I hope everybody had a good time tonight. It looks like we have 2 people joining us right here at the end. Sorry that you're joining us right at the end. But happy that you swung through in any event. We will be back. What day is it? What day is it? Time and space. Okay. We'll be back tomorrow. At about the same time. I normally start at 4 p.m. US Central. If I do have an earlier stream, it will only be in the 9x16 format, and it's usually like a gaming thing or similar. But programming will start 4 p.m. US Central, and will run however long my plans last. But again, I hope everybody had fun tonight. If you like what you saw and would like to see more, remember to like, comment, subscribe, all of that good stuff. It'll help you get stuff from my feed more often. With all that said, I hope the rest of your day is good, and I will see you next time.